Assalamu alaikum wa rahmatullah. Welcome everyone to Quality Control. And today, inshallah, we will talk about chapter 15. We will continue in solving the examples for accepting sampling. And we stopped in the last session on this example, and I asked you to practice it at home. And today, compare your results with the solution that we will do it together. The problem here is about a sales department purchase pins from a vendor that give away at trade shows. The shipment of the pins has a lot of 5,000 pins, and the sales representative wants to implement a sampling plan so that the entire lot of pins is either accepted or rejected. The sales representative and the vendor agreed to have the acceptable quality level, or the AQL, to be a 1.5% in the sampling plan, and the rejecting quality level is 10%. Create your sampling plan for the acceptance, and what is the probability of acceptance when the lot percent defective is 9.48%. First, when we have the AQL and the RQL given as a percentage, not as dimensions or measurements, then this is an attribute data. So when we conduct the sampling plan, we choose the sampling plan study for attributes, not a continuous or not for variables. And this is the first indication or first indicator or keyword you have to look for when you start solving the problem in Minitab. So here we have 1.5% and 10%. It could be a proportion or probability, or it could be number of defective per million, DPM. Those are attributes data or attribute information, not a variables like a thickness or dimensions. So we deal with those when we go to the Minitab. If you open the Minitab, you will go to Stat, then Quality Tools, and then you select the acceptance sampling by attributes. In this case, we select the accepting sampling by attributes. When you do select the attributes, then you choose whether the given information was for number of defective, a percentage like here, what we have in this question, or a probability if it was given as a probability. Now the question asks you to create the sampling plan for acceptance. That means you have to do the operating characteristic curve, and you have to also answer this question, which is asking the probability of acceptance when the lot percentage or the defective percentage in the lot is 9.4. So what is the probability to accept or reject the lot if we have a defective percentage 9.4? To do that on the Minitab, the result will be looking like that. First thing now, if the question asks you what will be the sample size and the acceptance number in the sample size, then you have to answer it based on the finding here. In this question, it didn't ask, but in previous example, it did ask about this. So here, the sample size found to be 52, and the acceptance number is 2. That's mean if you have less than 2 defective pins in this sample size, the 52, then you accept the lot. But if you have more than 2 defective pins in the 52 samples, then you reject the entire lot. The other findings that even though it was not requested is what is the probability of acceptance at the AQL level, which is set to be in the question as 1.5. So what will be the probability of acceptance, the probability of acceptance at the QL usually given here directly, and the probability for rejecting at the AQL is given here as 0.043. The same, the probability for acceptance at the RQL level, which is 10%, it was set. The probability will be to accept is 0.097, and the probability for reject, definitely it will be high because this is the RQL, this is the rejecting quality level. So it will be the probability for rejecting at the RQL, it has to be high, and the opposite on the AQL. And the average outgoing quality of the inspected pens after the inspection is being done, it will be 1.4 and it will be 0.95 at the RQL. What else information we can find is the figures here that is already generated by the Minitab, and in this case, to read those figures based on the question asks you here to generate the sampling plan for acceptance, and that is done already when you did the analysis and the figures. But it asks you also a specific question: what will be the probability of acceptance when the lot percent defective is 9.48? So if I have the percentage of defective in the lot, and I want to find the percentage of accepting that lot when I have this defective rate, on which figure in this case we will look at? We will look at the operating characteristic curve, because it will show us the relation between the lot percentage defective and the probability of acceptance. The probability of acceptance will be the y-axis, and the lot percent defective is the x-axis. And the percentage that he gave us, it was 9.48. So you have to look for 9.48, and you can see it here. I can use the pencil here or the pen. You can see it here is 9.48, and that is the associating probability of acceptance at that level will be 0.118, and that's how you find the probability of acceptance at any percentage of defective. We have solved previously about the relation of percentage of defective in the lot and the average outgoing quality. Refer or go to that examples to see how it is the relation. It's not common to use the ATI or the average total inspection. The average total inspection, just to show or to explain what is the meaning of that figure, that you will have it anyway, is to represent the average number of inspected items after the additional inspection and the rework is being done. So the ATI per lot represent the average number of pens inspected at a certain quality level of and a probability of acceptance. It is not commonly used, as it is the most common is the operating curve and then the average outgoing quality, as well as for the sample size number that is explained earlier in previous sessions, that is done using nonlinear equation to be solved, and the Minitab does that for you. This was for the example. I believe this is the fourth or the fifth example. I lost the counting of the numbers. But let's now share the screen and see how we can do this on the Minitab, so we can practice on doing these findings on the Minitab. So let's share the screen now. Okay. You go to Stat, and then you go to Quality Tools, and then you go to Accepting Sampling by Attributes. We have the AQL set either a percentage, number of defective per million, or probability of occurrence. Those, all of them, considered to be attribute information. If we have continuous information, like the next example we will solve, then we select the acceptance sampling by the variables. In this case, we will use the attribute, and then we go to this window. This window will show you the units of the quality level. In our case, it was percent of defective. It can be one of those three: proportion, or defective per million. We saw previously in some examples the other way of units of quality levels. Today we have a percent defective. It was given the AQL 1.5 and 10% for the RQL. The alpha and beta was given as so. The lot size was 5,000. When you press OK, then it will give you the answers that you have seen it in the slide. You can save those by pressing on the tab, and you copy them as a picture here. So you can put them on the Word document that you are going to use it in solving this question in the exam. I believe also you can send it directly to Microsoft Word. The same for all the results here. You can go to the tab or copy them, or copy the screen if you would like to. This is up to you. About the figure, how we find the result, you just double click on the figure here, and it will enlarge it. Then you can save this figure, or you can even add your own information like your student ID. You can add text here, and saving the picture, you just press here on the tab as well, and you can save the graph as, or you can send it to a Word or PowerPoint, or you copy it and then paste it somewhere else. When you double click here, any figure, any of those curves, you just double click on the line, or by one click it will just show the probability curve information or the data information for the result. Now you look for the percentage that you've been asked based on the the question. If it asks you about the probability of acceptance, then you will find it based on the given percentage of defective. If it's the relation between the probability of acceptance and the percent of defective or the quality level, then you look for the operating characteristic curve. If it's about the average outgoing quality and the lot percent defective, or the number of defective per million, or the proportion of defective, then you go to this figure, the AQ curve. And again, you just get your arrow next to the curve, and the screen will pop up about the relation between the two parameters. This is for the ATI is the same, even though, as we said, is not commonly used. And the sample size and the acceptance number, it is also given here in the summary of the figure. This is in the new version, I believe, of the Minitab. I think depending on the version you are using, some of these information, it will be changed how it will be present in your screen. But all the information will be usually given on the results here somewhere, if it is not in the summary of the figure. This is how you do it on the Minitab. Let's move on to the slide and see the next example when we have a variable data, and this is interesting case. Let's open the slides. Okay, this is the last example we have for the acceptance sampling. But in this case, we have it for variables, and it is a unique case and interesting to have. It has a different perspective, how you look to the accepting and rejecting the lot. And by the way, we have talked about that. Sampling or sample size or studying the sampling, it depends on the method you are using. For example, here we are using first a different type of data. It is variable, or the quality level, it is based on a variable criteria, not attribute. The second thing that we are using here, the first time specification limits, not average quality level or number of defective or proportion of defectives. Also, confidence interval, it can be used to find the sampling size. And depend on the method you are using. As we talked earlier, there is no one unique method for all the type of the sampling. Depend the cost, depend on the testing type of the cost, how much it will cost you to conduct the test for the sample size. We have talked if we are going to have a sample size like equipments or complex machines or cars. It is different than when we talked about the pens. Testing pens is not like testing cars, definitely. So conducting the sampling, it will be based on the method you are using, based on many other factors. And it goes beyond than this chapter. In advanced courses in quality, you can expand the investigation about the sampling. Today we have this example about a camera manufacturing. Receive a shipment of 3,600 lenses. So you can assume that, or compare it to your smartphones. The smartphones, usually they are not built all the parts in one factory or by the same company. We know that companies use from each other's parts, and then they use their own other parts to have their final product. So this is an example. A camera received the lenses from other factory in shipments. The 3,600 lenses, several times they receive it per week. The quality team takes samples of 259 lenses from each shipment and the thickness to determine whether to accept or reject the entire lot. So the criteria here, it's about the thickness. You can see that the thickness, it's a variable data, is not attribute, it is dimension, it is centimeter or millimeter. So this is the criteria how you are going to reject or accept. Is different than the previous example when we talked about the AQL. In that time, it was a percentage of defective found on the pens. The pens criteria, maybe it's easier, like something visual. You can tell that is not working or it's working. It is filled with ink or no. It is attribute data. Here we have variable data. So this is the criteria to make the decision. A defective lens, that is the thicker than 0.415 inch, which is the upper specification limit. So the USL here, or the upper specification limit, set to be 0.415 inch, and the LCL, or the lower specification limit, set to be 0.395 inch. Now the question asks you, do you accept or reject the lot? Or and the other question asks you, imagine or assume that there is agreement between the supplier and the manufacturer, and they agree both to have AQL is 100 dpm and RQL is 600 dpm, alpha set to be 0.05 and the beta is 0.1. Okay. Now we have two parts in this question. We have the part that about to accept or reject the entire lot, and there is a part that shows you or gives you an information or further information about the supplier and the manufacturer agreement. The first part can be solved, but you need a certain constant. We have talked briefly previous lecture about it, which is the critical value K, or the Z value K. It compares the quality of the shipments sample based on the Z value, compare it with the upper and lower specification limit set by the manufacturer. How we can find these values, how we can answer this type of questions. By the way, here the question give you the readings for the 259 samples, because we will need those readings to find mean standard deviation of the entire sample size. This is the readings. It was given here. When you will have the PDF file, you can enlarge it and you can reading those values clearly. I will just zoom in here. So these are the 259 readings for the lengths, the thickness for the lengths that in the sample. And let's go back here. Yes. And the upper and lower specification given, as well as the lot number. So what we will do in this case, how we get our result, how we make the judgment for the this sample size. The first thing, as we said, we have to find the critical distance, or the K constant value. This critical distance, it is a critical value. We can compare it to the number of defective when we have the sample size. It is similar, but here we are not having an attribute data. We have variable data. And in the variable data, we are using the Z value, the K value, which is a Z value at the end. The Z value, you got it from the probability of occurrence that is above the UCL and below the LCL. Calculations for this K value, it is given here for your extra and on reading. You are not going to be requested to conduct this analysis because it is beyond your level, but the Minitab does that for you, and I will show you how you can do it on the Minitab, and you get the or can use this value to make the judgment about the sample size. This value by itself, it is useless. We have to use this value for further calculation, and then we can make the judgment about the result. The acceptance criteria here, compared to the previous examples, we used to have the sample size, and then we use that sample size based on the number of defective that is given here. Usually, if we go back and see the results, how it looks like, you see here, we have the acceptance number. This is the acceptable number of defective in the sample. That means if you have 2 pens here or less, you will accept the lot. If you have more than 2 defective pens, then you will reject the lot. There we don't have this acceptance number. We have something called the critical distance, or the K value. The K value found to be is 3.449. How we get that? Basically, we get this value as we did previously in using the acceptance sampling, but it will be by the variable. Instead of using attributes, we will use for the variables. I will show you how you do that on the Minitab, and then I will explain the results here on the right side because it will need further calculation. So let's go to the Minitab for first part here, and then we explain the second Okay. I have to have the slides here next to me so we can get the values. We go to stat and then quality tools and then acceptance sampling by variables. And then we select the create and compare using creating sampling plan. And then we select the percent, since it was given as a percentage, the AQL and the RQL. The AQL, it was given as a percentage or defective. Let's go back to the slide. This one is missing the information. So please just bear with me. Okay. Now let's go to the stat and then quality tools and then enter the data. The defective per million here, it was given the agreement between the manufacturer and the supplier. It was based on the manufacturer, and the supplier, yes, was DPM, defect per million. So it will be 100 for the AQL and 600 here for the RQL and 0.05 for the alpha and 0.1 for the beta. The lower specification limit was 0.395 and the lot size was 3,600. So now we press OK and we get the value of the critical distance, which is the 3.449. Still, we cannot make the judgment about the sample size to accept it or reject it, but here we got the first element that we will use it to make the decision about the acceptance or rejecting. The acceptance or rejecting, it will be based on the value here, the 3.449. Now let's explain the other part or the second part about the making the decision. Let's go to see the questions here and stop sharing the screen. We are going to use the USL and the LSL. I will explain to you now. Now we need to have the K value first before we make the judgment about the upper and the lower. It is two steps. The first step, that you are going to use the information given here, that is about the agreement of the manufacturer and the supplier, which is the AQL. It was given here as a defective per million and 600 DPM for the RQL. We used also the lower specification, which is the 0.39, and the patch number to have the value of the K or the constant K to make the decision. Now we need this data or these readings of the lenses in addition to the upper and lower specification to find this result. This part of the result here is not from the same analysis. It needs additional step on the Minitab, which I will show you, and let's interpret the data first, and then we go back and see how we do it on the Minitab. Now you recall, now we have done the analysis to find the critical distance, the K value, and we found it as a 3.449. We will do additional step to compare this value with the Z lower specification and the Z value for the upper specification. We have the upper and lower specification as a dimensions or as a variable data, but we don't have it as a Z level. We cannot compare it in this format. We have to have the Z value, which is from the normal distribution table that is based on the probability of having a value that is less than the lower specification and probability of a value that is more than the upper specification from the readings of the 259 sample that you collected. And then you compare the value of the 3.4 that you have found on the last analysis we have done, and then you make the decision. If the value of the ZL SL and the ZUSL is less than the critical distance, then you reject or you make the decision as a rejecting the lot. Let's see how we can do that on the Minitab, and then we see the results, how it looks like on the Minitab, how we enter the data on the Minitab, because here we will use the same stat and then quality tools and then accepting sampling by variables. But in this case, we will use a different category that will take all the readings that is given for the lenses and put the upper specification and the lower specification, as well as you have to put the critical distance or the K value for the comparison. That's why we needed to find the K value first before we enter or we do the comparison. That step only to find the K value that we found it here. Then we will use it to compare it with the Z value of the upper and lower specifications. And the mean standard deviation that you see it here, it's for or from the sample of 259 readings that is given in the question. So now let's open the Minitab and see how we can do that on the Minitab. Now on the Minitab, I have entered the data for the thickness of the lenses for the 259 items in the sample. These are the value of the thickness of the lenses for the 259 item in the sample. Now we go and conduct the decision or rejecting analysis for this sample size. How we will do that? We go to stat again, quality tools, accept sampling by variables, and then we select accept and reject lot. When you select this option, that means you have readings, variable readings. You don't have create and compare based on the decision criteria like we did before. We did it before just to make the analysis to give us what is the decision value of the K or the constant K. And then we will use the constant K for the given readings from the manufacturer for those lenses. Now we go here and enter the information needed. For the measurement data, you will select C1, which is the thickness reading for the sample size. And then you enter here the value that you found from the previous analysis, 3.4, which is the critical value that you will use it to compare the Z value of the lower specification and upper specification. Those lower and upper is given in the question. Now, when you press OK, the result will look like that. The decision is given here stated as a rejection. And this is the part where you have to answer, you reject or accept. But how we knew that we reject or accept, we need to compare it with the Z value of the lower specification and the Z value for the upper specification. You compare this critical distance K value with them to make the judgment. The mean and standard deviation, it's calculated based on the readings for C1 values of the 259 sample. And the sample size was definitely 259. Also here you can copy and save the answers. Let's go back to our slides and explain them. You know that how we do the analysis now on the Minitab for the accepting sampling by variables. Okay. So here, when we make our analysis and we make the decision, we have to find it in two steps. The first step, to find the value, which is the criteria for making the decision. In attribute data and in the previous examples, we used to have the criteria as the number of defectives, but here it was given as an upper and lower specification. It was not given as a number of defectives. Otherwise, it will be easy by having how many defectives in the sample size to make the decision. But when we have upper and lower specification for variable data, and then you want to make the decision, you need to find the critical distance value first, and then you compare it with the Z value of the upper and lower specification from the readings that you have of the sample size. This means if you have 259 lens from this 3,600 shipments, if the Z value are greater than the critical distance and the standard deviation is less than the maximum standard deviation, then you accept. So you compare the Z values here for the upper and lower. If the Z values greater than the critical distance, then you accept. If it is less, then you reject. Also, the other criteria for the comparison is the standard deviation that is found here. If it is less than the maximum standard deviation, then you can also accept. But in our case here, the standard deviation is greater than the maximum standard deviation, as well as the Z value for upper and lower specification is less than the critical distance. And in this case, we reject the lot. So that's why we needed the K value in order to conduct this analysis and make the decision. That was the last example here for this chapter. There is an extra website that I would like to share with you to show you how also the number of sample or the sample size can be found from by using different method based on the technique that you are using in your manufacturing or as a supplier or as a consumer. Let's share the screen and I will share with you this website. It is a useful website that you can use it later when maybe if you need it in your work. It will be based on the confidence interval. It is surveysystems.com. I will put the link on the chat box to share it with you. In this website, you can have determine the sample size using the confidence interval. For example, if you have the confidence interval as a 3 or 4, and that's mean the difference between the upper and lower in the confidence levels, and you put the population or the lot size, and you can select from the two options of having 5% of confidence level or 99% confidence level, and then you hit calculate, and that will give you the sample size needed for this lot, which is here found to be 462. This is also a useful link that you can keep it in your log or in your material that you may use it in future. Is not required in this course, but this is another way how you can calculate the sample size. This was for today's lecture, and today we can say that we have completed the chapter 15 material. In the next meeting and the next session, we will have the quality function deployment or the house of quality. And also this is very useful and interesting tool that is used by the designer and the producer or the company, considering the customer's requirements and their product or their service. Usually you are required to use such tool in the capstone project. So it is better to learn it here and use it, inshallah, in the followed courses when you have the 400 level courses. That's all for today's lecture. Thank you all for the listening, and the time now is for the questions.